If A, B, C are in AP, then the value of determinant is, the choices are 0, 1, x and 2x. So we'll see. Now, if A, B, C are in AP, then what will be the relation? 2B equal to A plus C. So call it 1, and we can make use of this result that 2B equal to A plus C whenever required. And now consider the given determinant. What is the given determinant? It is x plus 2, the elements of the first column, x plus 3, x plus 4, that is the second column, or x plus 3, x plus 4, x plus 5. In that of the third column are x plus 2a, x plus 2b, x plus 2c. Now, what you do in this, that you apply R2 minus, first of all it is better that you multiply R2, replace R2 by 2 times R2. That is, multiply the elements of row 2 by 2, and to compensate it, keep half outside. So keeping row 1 and row 3 as such, you have elements of row 1, x plus 2, x plus 3, x plus 2a as such, and elements of row 2 you multiply by 2, you have 2x plus 6, 2x plus 8, and 2x plus 4b, and keeping row 3 also as such, x plus 4, x plus 5, and x plus 2c. What do you find now? That if you add the elements of row 1 and row 3 and subtract the elements of C from row 2, you will get 0, 0. See. Now you replace R2 now by R2 minus R1 plus R3. See what you get. Half outside. Now row 1 and row 3 you write as such, that is row 1 x plus 2, x plus 3 and x plus 2a as such. Now look at row 2. Row 2, the first element is 2x plus 6, and the elements of row 1 and row 3 will also be 2x plus 6. So if from row 2 you subtract R1 plus R3, you get 0, 0, but the third element of it will be, it will be 4b, it is 4b, 2x and 2x of course will cancel, you will get 4b minus 2a minus 2c. In the next step we'll see how to tackle it, keeping row 3 as such, that is x plus 4, x plus 5 and x plus 2c. And now taking C2 common from row 2. Half is already out. Take 2 common from the elements of row 2. So this 2 and 2 will cancel. Now keeping the elements of row 1 and row 3 as such, that is x plus 2, x plus 3 and x plus 2a. And taking 2 common, you get 0, 0, and you get 2b minus a minus c. And the elements of the third row are x plus 4, x plus 5, and x plus 2c. And it is at this stage, just look at this element, 2b minus a plus c. From 1, as A, B, C, I repeat, are in AP. So over there we have written 2b equal to a plus c. So what about 2b minus a minus c? That will be 0. So replacing this result in the determinant, you get the first row again, that is x plus 2, x plus 3 and x plus 2a as such. And the second row you have 0, 0. And 2b minus a minus c also becomes 0. And the elements of the third row, that is x plus 4, x plus 5 and x plus 2c you keep as such. And now, obviously the value of the determinant is 0. Why? as all the elements of row 2 are 0. And we know that if any row, all the elements of any row or any column are 0, the value of determinant is 0. So clearly your A choice is the correct choice. If x, y, z are non-zero real numbers, then find the inverse of matrix A. The given matrix A is x 0 0 0 y 0 0 0 z. You know that A inverse, the inverse of matrix, is defined as 1 by determinant A into adjoint A. So let us first of all find the value of determinant A, determinant of this matrix. So if you expand along first row, you get x times yz minus 0, and other two elements are already 0 0, so you get determinant A equal to xyz. And now let us find adjoint A. How do you define adjoint A? You know, it is the transpose of the cofactor matrix, that is C11, C12, C13, C21, C22, C23, C31, C32, C33. And what are the cofactors? You delete the row and column through that particular element and evaluate the value of the remaining determinant with proper sign. You already know the proper sign: plus, minus, plus, minus, plus, minus, plus, minus, plus. Impose these signs. So now let us work out these cofactors and hence in turn adjoint A. So it is transpose of the first element. Your element is x. So if you work out C11, it will be yz minus 0, and of course with plus sign, so it will be yz. And the other two you work out will be 0 0, and then C21 will be 0, C22 will be xz, and the third element of second row will be 0, and you get 0 0 xy. So these are the cofactors. And now if you work out the transpose of it, then you get adjoint A, and because the elements of the diagonal remains unchanged, so even the transpose will be yz 0 0. You write the elements of first row in first column, second row in second column, and third row in third column. Still it will remain same. So anyway, this is your adjoint A. So now the required A inverse is 1 by determinant A into adjoint A. I write the formula again. You have already worked out determinant A as x, y, z, and adjoint A is yz 0 0 0 xz 0 and 0 0 xy, this matrix. So now dividing each element of the matrix by x, y, z, you get 1 by x 0 0 0 1 by y 0 0 0 1 by z. This is the required inverse A inverse of the given matrix. Now you just check the given options carefully and you will find that A choice is the correct choice. Now we are given a matrix and we have to find out the value. You are given you are given a matrix or